All right, in this video, we are going to solve these trig identity questions, or I guess prove these trig identity questions over here. Now, these are easier trig identity questions. This is a great place to start for grade 12 math. It's almost like grade 11 review for trig identities. Let's start by taking a look at the first question over here. We want to always work with the more complex side. So I'm going to work with the left side over here. And what I notice in this question is I can factor the top and I can factor the bottom. So that's most probably the first correct step to do here. I'm going to factor the top by difference of squares. That's cos theta plus sine theta times cos theta minus sine theta. And I'm going to common factor the bottom, so that's cos theta, and I'm left with cos theta plus sine theta. Next, I can just cancel cos theta plus sine theta. So I'm just left with cos theta minus sine theta divided by cos theta. If I compare this to the other side, there's no denominator on the other side, and there's a 1 here and a tan theta here, same sign. So I know if I split my denominator, I'll probably get that same solution. So I'm just gonna do the opposite of common denominator, which is splitting the denominator for each term. And then cos theta divided by cos theta is just 1, and sine divided by cos is just tan theta, and now we've got the exact same thing as the other side, so we've proved this trig identity. Let's go to the second question over here. Tan squared theta minus sine squared theta times tan squared theta. Addition and subtraction is generally more complicated than multiplication and division, so I'm going to work with the left side over here. There's no point factoring this because that's not factored on that side. So I'm going to convert this tan into sine square x over cos square x. Next, I'm going to make a common denominator. Three of the very common problems in these trig identities are either factoring common denominator or converting everything to sine and cos. So I'm going to make a common denominator here. I'm going to multiply the top and bottom here by cos squared x. So I have sine square x minus sine square x cos square x, and now this is all divided by my common denominator of cos square x. Next, I can notice I can common factor a sine square out of the top. So I'll common factor out sine square x, and I'm left with 1 minus cos square x. Then this is divided by cos square x. Now, this is almost the same as this. We notice that sine square and sine square are the same. So I just want to turn all of this into a tan square. I know that I can change 1 minus cos square x into sine square x by using the identity sine square x plus cos square x equals to 1. So if I move the cos square to the other side, sine square x is 1 minus cos square x. So I'll replace 1 minus cos square x over here with a sine square x. And then sine square divided by cos square is just tan square. So I just have sine square x times tan square x, which is basically the exact same as the other side. Let's go to the third question over here. In the third question over here, what I notice is the ending of both these identities have a negative cos square x. So I'm not going to even touch the ending at all. The right side is a bit more complicated, so I'm going to work with the right side, but I'm not going to touch that ending. So for these two terms, I'm just going to start by making a common denominator. I'm going to multiply the top and bottom here by cos square x. So I have 1 minus 1 times cos square x is just cos square x divided by cos square x, and this just remains exactly the same because that's the same as that side. 1 minus cos square, I just showed you we can convert that into sine square x. I don't know why I'm putting the equal signs. I don't need those for trig identities. Then the last step is extremely simple. Sine square over cos square is tan square x. And now, as you can see, we've mapped the other side. So that was a bit of an easy one. And let's go to this last question over here. Again, I want to work on the left side. It's more complicated. I just want to make a common denominator. So I'm going to multiply the top and bottom by 1 plus cos here and by 1 minus cos here. So 1 times 1 minus cos is just 1 minus cos theta. 1 times 1 plus cos is just 1 plus cos theta. It's all divided by a common denominator of 1 plus cos theta times 1 minus cos theta. 1 plus 1 is 2. Negative cos and positive cos cancel out. We're just left with 2 over 1 plus cos theta times 1 minus cos theta. So now we're getting really close to the solution. The top is the same. I just need to convert this bottom into sine square theta. So I'm going to multiply these two brackets out with my FOIL. So first times first is 1. Outside is minus cos theta. Inside is plus cos theta. And last is negative cos square theta. Negative cos theta and positive cos theta cancel. So I'm left with 2 over 1 minus cos square theta, which is just 2 divided by 1 minus cos square can be replaced with sine square theta. And now this matches the other side. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.